Hi everyone, welcome to Study Simplified. In the previous videos, we have seen the basics and examples of Laplace transform. In this video, we are going to see the properties of Laplace transform. So let us see the first property. If you have a function f of t, the basic Laplace of this function is what? Capital F of s, right? But if this time is changed to a into t, which means a constant is multiplied to a time, then the Laplace would be 1 over a into capital F of s over a. So example, if you have f of phi t, then the Laplace of this function would be 1 over phi, then capital F of s over phi. So this is the important property which is asked in the GATE examination. So make sure you are noting it down. Moving forward to the second property. The second property is the shifting property. As you know that if f of t is the time domain function and if you are taking the Laplace of this function, it would be capital F of s, right? Now, if e raised to at is multiplied to this function, then the position of s would shift at s minus a. So if it is e raised to plus at, the answer s would shift at s minus a. If e raised to minus at is multiplied to a function, s would be shifted at s plus a. Now you have to note, if the power of e is positive, then the shifting part is negative. If power of e is negative, then the shifting part is positive. Okay. So let us see one example. If I have to find the Laplace of e raised to plus at into sine bt, the answer would be b upon s minus a the whole square plus b square. So how this answer came? The reason behind that is simple. Laplace of sine bt is what? It is omega, let's say b, right? So b upon s square plus b square. Now you have to shift the position because e raised to at is multiplied to sine bt, right? So the position of s would be shifted at s minus a. That is the reason you are getting the answer as b upon s minus a the whole square plus b square. So I hope you understand the point. First is always find the Laplace of the given function, that is f of t, and then according to the second point you have to shift the position of s. If you have understood this, tell me the Laplace of e raised to plus at into t raised to n. Again, it's simple. Our function is t raised to n. Laplace of that is n factorial upon s raised to n plus 1. But this is not the final answer because e raised to at is multiplied to the function, right? So if e raised to at is multiplied, you have to do the shifting part. So s is s minus a, that is shifting of the position. So the final answer would be n factorial upon s minus a the whole raised to n plus 1. Now the third property is Heaviside shifting property. So this is very important because maximum questions are based on this property. Now Heaviside shifting property is when you have u of t in the picture. Whenever there is u of t, that is a unit step function, it is simple. You know the Laplace of u of t is 1 over s. What if the time is shifted? If the time is shifted, it can be t plus phi or t minus phi. Whenever the time is shifted, you have to use the Heaviside shifting property. It simply says that first we have to fix this bracket, this shifting part. So if t is shifted, what you have to do? Fix this shifting part. Then you can see there are two examples. If let's say t minus a is there, right? So t minus a, then the shifting would be at e raised to minus as. So here the value of a was phi, you are getting the answer as e raised to minus phi s. What if the time was shifted at t plus a? In that case the answer was e raised to plus as. Okay, so whatever is the part here, just raise that to the power of e. So if it is t minus a, then the power of e would be e raised to minus as, and if it is t plus a, the power of e would be e raised to plus as, right? I guess the first part is clear. Moving to the second part. Once the time is fixed, then you have to take the normal Laplace. So Laplace of u of t would be 1 over s. Multiply 1 and 2, the final answer would be e raised to minus phi s into 1 over s. So taking one more example, let's say if it was u of t plus 7, the Laplace of that would be, first I will take the shifted part, I will fix that, right? So e raised to plus 7s into Laplace of u of t would be 1 over s. So this is the final answer. Let us see some example on shifting property. The very first question is f of t is given as e raised to minus 3t into sine 2t. Find the Laplace of this function. Actually this question is easy. First we have to find the Laplace of sine 2t, which is 2 upon s square plus 2 square, right? Now according to the property, if e raised to minus at is multiplied to a time domain function, the position of s would be shifted. So here it will shift the position of s to s plus 3, correct? So just shift the position of s to s plus 3. The answer would be 2 upon s plus 3 the whole square plus 4. Do the expansion and you will get the final answer. Okay, so now we will see some level up question. You have to find the Laplace of cos hyperbolic of at into f of t. Now at the very first instance you don't know how to solve the question, but I have always told you, whenever you have two function multiplied, you cannot split the Laplace. If you cannot split the Laplace, then you should think for some techniques, like how can I convert this question into some trigonometric form or some exponential form. And if you look carefully, you can convert this part into exponential form, which would be helpful, like cos of hyperbolic theta is equal to e raised to theta plus e raised to minus theta upon 2. So you can say that here theta is nothing but at. The simplification would be cos hyperbolic of at is equal to e raised to at plus e raised to minus at upon 2. Now your question might be, what if instead of cos hyperbolic theta, if it was cos theta? Then I will give you one more formula. If it was cos theta, I am writing here, see, then the respective exponential term would be either you can say the Euler's identity or you can simply say the relationship in the exponential terms. It would be e raised to j theta plus e raised to minus j theta upon 2. So you should know the two formula, cos hyperbolic theta, cos theta. Similarly, sin hyperbolic theta, sin theta. You should know the respective formula. Once you simplify the question, now the next task is to use the property. So the first step in this question was the conversion part. The second step is the splitting of the function, right? So this is the first function, this is the second function, and whenever we have two functions in addition or subtraction format, we can split the Laplace. So Laplace of e raised to at upon 2 into f of t is what? It's simple. Using the shifting property, you can say that the answer is capital F of s minus a upon 2. This 2 is because of this constant, so 1 upon 2 is common, take it outside. So Laplace of e raised to at into f of t is what? F of s minus a. Similarly, Laplace of this term is what? Capital F of s plus a. This is the final answer. I hope you liked the video. All these concepts, tricks and techniques are important for GATE examination, because in GATE examination you have to solve more question in less time. All these techniques, tricks and concepts you will find in my engineering mathematics notes. So if you want to buy the notes, the contact and the email ID are on the screens now.
तो फ्रेंड्स, अगर आपको मेरी वीडियो पसंद आ रही हो, देन टू लाइक दिस वीडियो, शेयर विथ योर फ्रेंड्स एंड सब्सक्राइब टू माय यूट्यूब चैनल। तो मिलते हैं अगली वीडियो में। टिल देन टेक केयर, दिस इज श्रेनिक जैन, पीस आउट।